Hello guys, in this video we are doing electrolytic cell. So an electrolytic cell is an electrochemical cell which consists of one compartment, which is one container, and two electrodes, where the electrodes are anode and cathode. Yet anode in this case is the positive one. So in this case anode is positive, then cathode is negative. So an electrolytic cell consists of a cell. We have a cell or a battery to supply current. That current is used to start up the reaction, to supply current to commence the chemical reactions. So reactions in electrolytic cell, they need current for them to start up. It's not similar to galvanic cells where reactions are spontaneous. Those ones, they start on their own, but these ones, we need current to start the reaction because the reactions are not spontaneous. That's why we need a battery here. This is our cell or a battery. So for us to determine which one is the anode or which one is the cathode is determined by the terminal of the cell. The longer stick represents the positive terminal of the battery. So this is positive. The shorter one is the negative. So as we say that anode is the positive, so this is our anode. Then this is our cathode. These are electrons. And anode is positive, this is negative. Then we have electrolyte. Electrolyte, it allows the movement of ions from one electrode to another through the external circuit. So we're saying redox reactions in electrolytic cells are not spontaneous. So in this electrolytic cell, the type of electrodes that are used, we have two types. First one is the reactive electrodes. These ones, these electrodes, they take part. So meaning one of these electrodes will be corroding and the other will be gaining electrons. Because in this case, at the anode, there is oxidation takes place at the anode. And at the cathode, there is reduction. So what it means, if we are using a reactive electrode, is that electrode at the anode, for example here, that anode will be corroding, while this one will be gaining more weight, gaining more mass, because the ions are being transferred to the negative electrode. Then there might be the use of unreactive electrodes. These ones, they can be called inert electrodes, meaning they are not reactive. They don't take part in the chemical reaction that will be happening in the electrolyte. So unreactive electrodes Same processes will be taking place at both electrodes. But now what differs is unreactive electrodes, we find out they are not taking part on the chemical reaction. So examples of unreactive electrodes, we have graphite. Graphite is a carbon. That one is unreactive. We also have platinum. Then for reactive electrodes, we have copper. It's reactive. Magnesium is reactive. etc. It's a lot. Even here, we also have other non-reactive, unreactive electrodes. So now let's see the movement of electrons. So electrons flow from negative terminal to positive terminal, meaning electrons are like this. So electrons flow from negative to positive terminal. This is for the battery. So meaning they flow from cathode to anode. This is the reverse of the galvanic cell. An electrolytic cell can be used in the purification of copper, electroplating, extraction of aluminium metals by the process called electrolysis. Electrolysis is the decomposition of this electrolyte into its ion by the use of electricity. So, another application of electrolysis is decomposition of solution, such as copper chloride, we have water. There are many solutions that can be decomposed by electrolysis. So, let's see some few examples in the next video.